Now, there's not really that much to this lesson, although the second part of what we're going to do, it comes from the section that we actually did this in the last unit, even though it came from this, and we're going to just redo it because we didn't do very well on this when we took the test. But the two sections are, as you could see, 4.6 and 4.7. You know, I expect that the next class is the last lesson that we've got. So we meet on Tuesday, right? So that's the last lesson, and then we'll have review on Thursday, test on the following Monday. That's the way it should work. Okay. Okay, so there's that. So direct variation is just a kind of a straight line. It's a linear function. You know, if you compare, a direct variation has a standard formula, which is y equals k times x, right? The k is not a variable. X and y are variables. K is a constant that you don't know when you start the problem, but it is not a variable. X and y are variables. Now, if you look at that formula, y equals kx, and you compare it to what we're already using for a straight line, y equals mx plus b, what's the difference? What do you see up here about the b? There is none, right? So in a direct variation, b equals 0, right? That's why you don't see it. Now, we use k in front of x in a direct variation. Usually we use m in front of x. So what does that tell you about what is k? It's the slope, right? It is just another way to say the slope. Now, in this textbook, they use a. I've never seen any other letter used except for k, and the SOLs are very specific. K, K, K. You know, that sounds bad. It's got to be k. So if you look in the book and they use a, then I don't know why they did that. K has got a specific name. It's called the constant of variation. And I don't know how much we do other variations in this class. I think we do more. I think we probably do inverse variations. You know, we go way deeper into this in Algebra 2. But in any kind of variation problem, there's always a k, and the k is the constant of variation. And sometimes they're going to ask you for that. Solve for the constant of variation, and you're supposed to know what that means. So direct variation is a linear function where the y-intercept is 0, and instead of using m for slope, we'll use k for slope. Okay, so the first kind of problem is, can we tell whether these are direct variations or not? Well, what did we just say? You can tell whether a linear function is a direct variation if its y-intercept is 0. Well, how can you tell if the y-intercept is 0? It's not in slope-intercept form. You could solve for y and then see what you get, right? That's actually what they do in this book. So let's say I solved the first one for y. What would I do first? Subtract the 2x. Now I have negative 3y equals negative 2x. Come on. There we go. And then I divide by negative 3, and I'm going to get y equals positive 2/3 x. Is it a direct variation? Yeah, I mean, look it up there. B equals 0. So yes, this is a direct variation. dv. So looking at this problem, how else might you have told that, even before you solve for y? You can see that there's just a 0 there. You don't have a constant term, right? Like, what's going to happen when I solve for y here? There is a constant term. So, I mean, honestly, in the last book that I taught out of, we didn't actually solve for y. We just looked to see whether there was a constant term. So this one we'd have said immediately, that's a direct variation because it's just got a 0, right? And that's not a direct variation because it's got a constant term of 4. But we'll solve it just because that's the way they're doing it. Add x. Add x. Y equals x plus 4. So, is it a direct variation? And you say, no, because the b does not equal 0. So, not dv. Right, so we should be able to tell whether, yeah. Yeah, you do either one. I might not even put a question like that on the test. You know. My guess is I probably wouldn't. But. So go ahead and try those three. Are they direct variations or are they not direct variations? And you can do it either way you want. Just don't get them wrong. Right, so the first one's not because, I mean, you could solve for y, but you could see it's going to be, there's going to be a b that's not 0. Right? These are going to be direct variations. In order to know the k, though, you need to solve for y. Right? Subtract 2x. Y equals negative 2x. What is k? Negative 2, right? So you're not done until you say k equals negative 2.